So here we go at part 11. Just a couple of problems I just wanted to go over. Kinetic energy is always 1/2 mv squared. We know that, and if you look at the top figure over here, let me get a color here. Kinetic energy is 1/2 mv squared. So if you're given a mass, let's say the mass is 5 kilograms, you're given a velocity, 2 meters per second. You can always calculate the kinetic energy, take 1/2 the mass, in this case it's 5, times the velocity, which was 2. Don't forget to square the velocity, and if we square the velocity, we're going to get 4 over here. 4 times 5 is 20, and then multiply by a half, you're going to get 10. And the unit for that kinetic energy is joules, and that's a unit of energy. So now we want to look at our equations of motion. There was 3, 1, 2, and 3. These are the basic ones. This assumes you have a constant acceleration, and so you might find some examples where you're given an initial velocity, an acceleration, and a time, and you're asked to find the delta x. So delta x would be the displacement. Okay, that would be delta x would be your displacement. We want to know what is it. Well, we look here. We got time, acceleration, and vi. If you look at number 3, we've got time, we've got acceleration, and we've got vi. So we can use this equation to solve the very first problem. And so delta x would be equal to vi, which is 2, times the time, which we said was 5 seconds, plus the 1/2. The acceleration in this case is 2, and the time is 5 squared. So these 2's conveniently canceled. 5 squared is 25. 2 times 5 is 10. So delta x would be 35 meters in that case. Delta x is a displacement, so it's length. So you know you're going to have units in meters. How about, for example, this one over here? We've got vi, we've got a, and we've got t. We want to know v final. It looks like equation 1 can do it for us. So v final is vi, which is 5, plus the acceleration is 1, and the time happens to be 6. So in that case, it's very simply 11 meters per second for v final. Right. And you may have a case where you're given the final velocity, the initial velocity, and the displacement. In that case, you could find the acceleration. So these 3 equations are our basic equations for motion. We use them a lot, and you just need to identify what your parts are that you can plug into the equations then and make them work for you. Okay, just a couple of things to review on net force. So net force is the sum of all the forces, all right, all the forces. So if they're going in different directions, usually we consider to the right as plus, and this direction will be minus. So when we add them all up, we'll see what we got, and we find out if we have a net force. So here, this could be a tug of war going on here. We got a blue vector applying a force of 150 newtons to the right. We got the green or yellow vector with 100 newtons to the left. So what is the net force in this case? Well, we got plus 150 newtons because it's going in the plus direction. And then we got minus 100 newtons because that's going in the negative direction. If we add those 2 up, because we want to sum up all the forces, and there's only 2 forces here, so we sum these 2 forces up. 1 again here is positive, 1 is going to be negative because it's going the opposite direction. So when we sum these 2 forces up, we come up with an answer of 50. 50 newtons is the net force, and lo and behold, it is a positive value. So the net force is going to be 50 units, or rather 50 newtons to the right. If we got a minute, I could just talk to you a little bit about momentum. Momentum is mass times velocity. So you can find momentum simply by multiplying mass times velocity. If, for example, we have 2 balls, we have, let's say, ball A and ball B, and let's give ball A a mass of 5 kilograms and ball B a mass of 3 kilograms. But let's make the velocity of A 2 meters per second and the velocity of B 5 meters per second. So which ball has the greater momentum? Well, momentum is mass times velocity, so we just take mass times velocity, 5 times 2 for A. The momentum is going to be 10, and the units again are kilogram time meter per second. For ball B, mass times velocity is going to be 3 times 5, which is going to be 15 kilograms times meters per second. So this momentum's 15, this momentum's 10. The ball with the greater momentum is, in this case, ball A. So I'll stop this video and we'll continue with another video and do a couple more problems later.